So we're trying to find the LCM and the HCF of this set of numbers. Okay, LCM simply
Okay.
means, yeah, LCM simply means a number that the two or three or more given numbers will divide. And oftentimes, it's usually either the size of the biggest one or bigger than the two. That is talking about LCM. But HCF, on the other hand, is a number that will divide the two or more given numbers. So it's either it is the size of the smallest one or smaller than the two numbers. You can see LCM and HCF, they are like word and opposite. Is that clear?
Yes.
Okay, we're going to start from this option G. To find the HCF or LCM, we're going to divide. We use division method. So 55, then 1 to 1. So we're looking for numbers that can divide the two of them at the same time. That if it's dividing 55, it must also be dividing 121. Okay,
Okay.
good. And that number that we're going to use, we can start with any of the prime numbers. So this is, I'm using 2. 2 cannot go. So I won't use 2 because it can go in any one of them. If I use 3, 3 2 cannot go. If I use 5, 5 can go in the first number, but it cannot go in the second number. So the next prime number should be 11. 11 can't. 11 can go in the two of them. Let's say, okay, 2, 3, 7. 7 can go. So that's why I'm using 11. So 11 in 55 is 5.
Okay.
And 11 in 121 is 11. Because 11 times 5 is 55. And 11 times 11 is 121. Again, let me start. I said I want to use prime number, and we know our prime numbers to be 2, 3, 5, 7, 11, 13, and so on. These are numbers that nothing can divide apart from those numbers themselves and 1. So,
One.
yeah, good. So as I pick 2, 2 can go, 3 can go. You can't divide them at the same time. 7 also cannot, but I pick 11. So 11 can. 11 in 55 is 5, and 11 in 121 is 11. Now, look at 5 and 11. Nothing can divide 5 and 11. So, since nothing can divide again, then we have reached our answer for HCF. HCF equal to 11. But what about LCM? We'll continue dividing with whatever can divide each of them. That is how we get our LCM. I said LCM. So now, what number can I use now? I can use 5. It will divide this, but it won't divide this. So let me change the color so that we can see the difference in those answers. So I use 5, can divide this, that is 1. It can divide it, that's 11. Then I can use 11. This one remains the 1, and 11 in 11 is 1. So the combination of the 3 now is our LCM, which is going to be 11 times 5 times 11. And if we multiply, okay, can you hear me now? Yeah, can you hear me now?
Yes.
Okay, I think the network is bringing the video, taking the video away. It's going to come up now. Let's see. Okay, okay, fine. So, do you understand what I have done here?
Yes.
Good. So now if I multiply 11 times 5, that's 55 times 11, that gives me 605 as the LCM. So if we're dividing and nothing can divide both of them again, we stop, and that's our HCF. Then the next note is that when we continue dividing until nothing can go in either once again, then we have the LCM. So let's try the second one, which is option H. Let's say
Okay.
H. We have 24 and we have 42. So dividing between them, we're going to use our prime number as usual. So let's say we have 2 in this. 2 in 24, that's 12. 2 in 42, that's 21. Okay?
Okay.
Now, 2 can go again. We can use 3, which is the next prime number. 3 in 12, that's 4. 3 here, that's 7. Now, nothing is common to both of them. We have reached our HCF, okay?
Okay.
So, the HCF equals to 2 times 3, which is 6. But talking about LCM, we continue further, okay?
Okay.
So 2 can go here, 2, it can go here. 2 can go here, 1, it can go here. And 7 can go here. So with that, we say our LCM equal to all of the 2's, 3 of them. So 2 raised by 3 times the singular 3 times the 7, okay?
Okay.
Now, 2 raised by 3 means 2 times 2 times 2, and that is 8, okay?
Okay.
And 8 times 3 gives us 24, while 24 times 7 gives us 168, okay?
Okay.
So the LCM of these two numbers are 168. Okay, let us look at the remaining 4. Let me take it to the other side. So the next one, finding the HCF and LCM, we have 80 and 96. So to find the HCF and LCM of 80 and 96, again, we're going to divide with the prime numbers until nothing can go in both of them for HCF. So I
Okay.
have this here. I have this. 2 can go in both of them. So 2 here, 40. 2 in 9 is 4, making 1. 2 in 16 is 8. 2 can go again. 2 in 40 is 20, and 2 in 4 is 2, and 2 is 4. 2 can go again. 2 in 20 is 10. 2 here is 12. 2 can go again. 2 here is 5, while 2 here is 6. Nothing is common to them again. That's our HCF, okay?
Okay.
Highest common factor, HCF, equal to 2 in 4 places, 2 raised power 4, and that is 16. But for our LCM, we have to continue further. So 2 can go in this one to give me 3. It can go here. So 3 can go in this one to give me 1. It can go here. And 5 can go in this one to give me 1. So 1 remains here. Now, for the LCM, we have the combination of everything. So how many 2? 1, 2, 3, 4, 5. Then 3 and 5. So 2 raised by 5 times 3 times 5. 2 raised by 5 is 32. 32 times 3 is 96. And 96 times 5 gives us 480. Okay,
Okay.
good. Then we look at the next one, which is option K. We have 64 and 288. 64, 288. To find the HCF and the LCM again, we're going to rule out our division line. So we have to divide, say, 2 can go. 2 here is 32, 3 and 2. 2 here is 1, 2 here is 4, 2 here is 4. Okay, this was the one you did, and I think you got it. So 2 here is 16, 2 here is 7 and 2, in 14, 7 and 2, in 4, that's 3. So 2 here is 8 and 2 here is 36. 2 here is 4 and 2 here is 18. And 2 here is 2, while 2 here is 9. Now, nothing is common to them again. This becomes our HCF. Exactly.
Okay.
So HCF equals to 2. How many? 1, 2, 3, 4, 5. And that is 32. But for the LCM, we continue further. So we have 2 can go here, 1 can go here. Then instead of using 3, we can as well just use 9 since this is 9. So because if we use 3, it will still we'll still use it again, which is double steps. So we have how many 2 now? 1, 2, 3, 4, 5, 6. 2 raised power 6 times 9. And 2 raised power 6 is not 2 times 6, but 2 times 2 times 2 times 2 times 2 times 2. That is 64. 64 now times 9 gives us 576. Okay?
Okay.
Yeah. Then the last aspect, which is the remaining 2, let's move it to the next page. So to this page, we want to find also the HCF and the LCM. So we're going to divide all through. Okay. So the first number there is 90, and the next one is 189. So here, if I use 2, 2 can't go in 189 because it's odd number, so I can use 3. 3, in 9 is 3, then 0, that's 10. In 18 is 6, and then 3. 3 can still go. 3 here is 10, while 3 here is 21. Now, nothing is common to both of them again. So we stop it there as for the HCF, okay?
Okay.
That is 3 squared, which is 9, which is 3 times 3, and that's 9. Now for the LCM, we'll continue, we'll proceed further. 2 can divide this, that is 5. You can divide this, that's 21. Then 5 can divide it, okay, I can use 3. 3 can divide the second one, cannot divide this, so that's 7. Then 5 here, 1, this is still 7. Then 7 here, this is 1, and this is 1. So for the LCM will combine all of these. How many? 2, only 1. Then 3, that's 3. And 5 and 7. So that is 2 times 27 because 3 raised power 3 is 27. That's times 2, gives us 54. Then times 5, that's 270, and times 7, that gives us 1,890 as the LCM. Then the last one, another list, which is option N, we have 252 and 490. So to find the HCF and the LCM of these two numbers, we also divide through the way we've been doing all of the rest. So they are even numbers, so 2 can divide them. And 2 here, 1, 2 in 5 is 2. Then 2 in 12 is 6. While 2 in 4 is 2. 2 in 9 is 4, making 10 and 5. We can see that 2 can divide them again, okay? Because one
Okay.
of them is odd number. But let us try if 3 is going to divide them. Let's say 3 will not divide them together. So we can take our um, HCF. We can say our HCF is 2 if nothing will divide them altogether. Is that clear?
Okay.
But let me confirm 252 and 490. If anything, we'll be able to divide all through. Let's see. Yeah, think, let me check if 7 is going to divide them. Okay.
Okay.
If 7 is going to divide, let's say, okay, let's see this one. 7 is going to divide them, okay? Is that
Okay.
clear? So 7 in
Yeah.
12, 7 in 12 is 1, remainder 5. 7 in 56 is 8. And 7 in 24 is 7, okay? I mean, it's 3, which is 21. Is that clear?
Yes.
And remainder 3, 7 in 35 is 5, okay? So with this, we
Okay.
can be sure that nothing divides them at the same time here. So the HCF equal to 2 times 7, which is what? 14. So for the LCM, we'll
Yeah.
proceed for them. I say we can use any number that can divide each one of them. So this is 2 can divide this one, that's 9. This is still 35. 3 can divide this one, that's 3. It's still 35. Then 3 here, that's 1, this is 35. Then this here is 5. So 1 here, that is 7. And 7, that's 1. So for the LCM finally now, we have how many twos are there? That's 2. How many threes? That's 2. Okay.
Okay.
How many 7? That's 2. And how many 5? That's 1. So let's write 5 before the 7. 5, then 7 all squared. So here we have 4 times the 3 squared is 9. That's 36. Then times 5, that's 180. Then times 49, that is 8,000. That's 7 squared is 49. So 8,820. 8820. Is that clear?
Yes.
Okay, so with that, I'm going to send you these notes, then I will send you the assignment.